Hello friends. Today I am going to tell you about asteroid shock waves could have provided the building blocks for RNA. If you not subscribed our channel yet, then please subscribe it and then also click on bell icon. Let's start. A now famous experiment conducted by chemists Stanley Miller and Harold Urey back in 1952 showed that even if we don't know for sure how the first living cells formed, at least some of their molecular building blocks could have been produced by simple chemical reactions under conditions on ancient Earth. Now, more than half a century later, researchers from France and the Czech Republic have used a similar experiment to expand this list of potential ingredients to include all 4 RNA bases, filling in some possible stepping stones on the pathway from chemical soup to the origins of life. While the results don't show how life probably formed, they do demonstrate that conditions on Earth roughly 3.5 to 4 billion years ago could have been sufficient to produce the toolbox of compounds necessary for biochemistry. Those conditions include what was probably an atmosphere without oxygen, referred to as a reducing atmosphere, and warm bodies of water containing nitrogen and carbon-based molecules such as ammonia and methane. Miller and Urey dissolved these two compounds in a sterile flask of water with some hydrogen gas for their experiment, letting it sit for a week before shocking the solution with electricity to simulate lightning strikes. In their brown goop, they discovered the amino acids glycine, alpha-alanine, and beta-alanine, with hints of aspartic acid and alpha-aminobutyric acid, demonstrating that at least some of proteins' building blocks could be made without the help of complex biological processes. It later turned out that Miller and Urey's resulting crud contained a lot more than 5 amino acids. A study of their preserved material in 2008 using better analytical equipment isolated 14 amino acids and 5 amines, with even more recent analyses by one of Miller's students suggesting up to 40 compounds could have been produced. While it has been lauded as a landmark experiment, it's not without its critics, with some chemists arguing there's no clear evidence that our atmosphere was a reducing one, and the materials they used might not have been so plentiful back then. This most recent variation on the experiment led by the Czech Academy of Sciences wasn't on the hunt for amino acids this time, but for another organic building block called formamide. Polymers of RNA are made of 4 different kinds of unit: adenine, guanine, cytosine, and uracil, all of which can be made from formamide. Various suggestions have been put forward on where this RNA base precursor might have come from. However, in most cases, the exact chemistry of such systems has not been well explored either experimentally or theoretically, the researchers write in their published report. Like Miller and Urey, the experimenters reasoned the atmosphere was probably slightly reductive on ancient Earth, but their version substituted the original experiment's methane for carbon monoxide and left out the hydrogen gas. As predicted, their resulting soup contained significant amounts of both formamide and hydrogen cyanide. The formamide molecule does not directly play the role of starting substrate, but it is rather a suspected intermediate of reactions leading from simple model prebiotic mixtures to biomolecules, the researchers wrote. In other words, they still needed to show the formamide could be encouraged to react into the RNA bases through application of UV radiation or some other catalyst. Another possibility could be the plasma from an intense shock wave, like those produced by asteroid impacts. Since launching boulders into chemical flasks is impractical, the team opted for the next best thing: intense bursts of light from a terawatt-sized laser system. WE detected all of the RNA canonical nucleobases, uracil, cytosine, adenine, and guanine, together with urea and the simplest amino acid, glycine, the researchers wrote. THE's findings support the idea that ONH3 plus CO plus H2O atmosphere can substitute for pure formamide and act as a starting environment not only for the formation of amino acids, but also of RNA nucleobases. While the amounts they found were tiny, They did demonstrate the pathway from a few common compounds to RNA was at least plausible in a reducing atmosphere, even if those conditions existing on Earth are still contentious. The team also showed that the nucleic acid bases could break down into products that help make the atmosphere more reductive, products that in turn can react to turn back into nuclear bases. Not only does this hint at reactions that could have set the stage for life generating here, it helps provide us with signs for potential life on other worlds with reducing atmospheres, such as Saturn's moon Titan. Rewinding the clock on evolution, we eventually get to a point in time where models based on competing genetics inside replicating cells can no longer explain the origins of life on Earth. Experiments such as this one might not definitively show how life assembled from atoms, but they do go some way in revealing possible stepping stones that life somewhere in the universe could use to emerge. Thanks for watching. Please subscribe for more interesting videos.